Let's see. There we go. Good evening, everyone. We had a little mic problem there. Welcome to Dome at Home. I'm your host, Scott Young, and I will be running the show this week. It's nice to be back. First show in August. I'm jumping ahead already. And we're quite happy to be back. We've got a great show lined up for you today. As you know, Mike, my colleague, is away for the summer, so I'll be watching the chat. And there we go. Thanks, everyone, for everyone that pointed out that the mic was off. I think we're doing good now, though. I think I've solved the volume issue that we had over on the YouTube side. And we're also trying something new with this new chat program. The chat from Facebook is getting automatically posted to YouTube and vice versa, so that if someone on one channel asks a question, everybody will actually see the question and you can all interact. One of the great things we love about this show is sort of the sense of community and how people are answering each other's questions and chiming in and stuff like that. So we like to encourage that. And so hopefully this will make that a little bit easier. And it also means that I can see all of the chat working at the same time, which is fantastic. All right, we've got a great show lined up for you today. It is coming up to the dark of the moon, the time when we have new moon, no moon in the sky. We're only seeing the dark side of the moon, essentially. And that's a great time, particularly in the summer, to get out of the city if you can. I mean, often we think, you to get the best view of the stars, you leave the city, you go away from city lights out into the country. If you do that on the night of a full moon, you're probably wasting the drive in some ways, because the full moon really lights up the sky, and no matter how you drive, you can't get away from it. So if you really want to get the maximum darkness, you want to go around the time of new moon and also go away from city lights. That reduces all of the sources of light pollution that block out those fainter stars and really gives you an amazing view of the sky. So that's what we're going to be talking about this week. We will also be talking about the upcoming annual Perseid Meteor Shower, which happens basically right around our next show next week. So Wednesday and Thursday. Actually, the shower is on now, but it's the peak activity is coming up. So we'll get you all ready for that. And of course, cool space stuff, all the things that have been happening up there in Earth orbit since last show. All right. First of all, it was a big day down at the museum and planetarium today. We welcomed people into our building, and they came and they saw things. It was really, really nice to see people. We're doing a promotion right now. Everybody gets to be a kid all the way through summer. So basically, everybody pays the kid price, which I think is something like $9 or whatever for everything. It's pretty good deal. And right now, the museum galleries are open with the brand new Prairies Gallery. And of course, the planetarium. The planetarium is running 3 shows a day. And there's a special one for younger folks at the beginning of the day at 1 o'clock. Our live Manitoba Skies show at 2:30 is sort of the classic planetarium program. And then at 4 o'clock, Ice World, sort of a documentary about the many worlds in our solar system that have ice on them and what that tells us about the possibilities for life and also just the possibilities for exploring those places in the future. It was really great. I was down there just as the lineups were forming. It wasn't super, it was busy enough that we felt good, but it wasn't so full of people that people were feeling nervous or anything like that. We still have masks, we still have social distancing, limited seating in the planetarium, and everybody's seated in their own little cluster away from everybody else. So it worked pretty well. I got the chance to meet one of our viewers. Walter was there with his mom. They watch the show every week, and I just happened to be walking through the foyer while they were buying their tickets and got a chance to say hi. So hi, Walter, nice to see you, and thanks for coming down and supporting the museum and the planetarium, you guys. All right. The other thing that I managed to do when I was down there in the office, I've been working from home for months at this point. I can't even remember how long it's been since I've been in the office, but I was in there today briefly, and I got a chance to get some of my mail. And oh, hi, Pascal. Oh, okay. Now I put the face and the and the names together. I meet people on the chat here, and then I meet people in person, and sometimes I don't make the connection. So that's fantastic. It was great to meet you guys, and yeah, it was pretty cool to see you. Ben has pointed out that we also have a sale on memberships, 20% off memberships at the museum right now, which is a screaming deal as well. So very cool. Yeah, I managed to go into the office and get some mail. And one of the cool things that I got to do was I picked up a lovely little card that was sent in from Rowan and Melissa and Ryan. Thank you so much. They've been loyal watchers out in Courtney, somewhere out in BC, like around that area, I think. But it was really, really sweet of you to send us the card and everything like that. Nice heartfelt message. And I got this, actually I have to, here, let me turn off my green screen so that you can actually see here. We'll just take a second. But I got this really awesome, there we go, there's the actual studio. And I got this awesome rocket ship that Rowan made for me. I had to turn off the green screen because there's some green coloring on there that would disappear otherwise. Thank you so much for that. I'm keeping it on my microphone because as a reminder of all the great people that are out there. Okay, let's jump into the sky. If we go outside, we've still got the sun up. It's still pretty late of a sunset. It's still not getting dark really, really early. That time over the course of August and into September will really get earlier and earlier each night though. And it won't be long before we're thinking, oh wow, it's dark too early. Let's see. As the sun goes down, we've still got Venus low over there in the west. It's staying very low. As we mentioned, the angles are just such that this particular year around, Venus is going to be very, very low in the west. If you head out at 10 o'clock, it might be too late already to see Venus. So you really need to get out there just as the sun is setting. And it'll be the first star you see at night. It'll be the brightest thing in the sky. So Venus is still up there, still worth watching for, but it disappears soon after the sun. And once the sky is fully dark, Venus is already gone as well. But the dark sky is sort of our feature right now. And so if we start to look around at the dark sky, I mean, we have all the constellations that we've been talking about each week. You know, they slowly change. You know, over the course of a month, they change their general position a little bit, but they're still up there. You know, we still got the Big Dipper up here over in the northwest. You can still follow the arc of the handle here to Arcturus, the bright star, in Boötes the herdsman, which looks like, oh, let's pull it down a bit here, which looks kind of like an ice cream cone with a big blob of ice cream on it. We swing over towards the southern horizon. We can see, here we'll zoom out quite a bit. High up in the south, we still have the summer triangle made of the bright stars over here. That's, you know, been up there for a while. Down below the summer triangle, we have the planet Saturn and the planet Jupiter. We talked about them in detail last week. They're up there, very, very bright. They outshine the stars, so they're pretty easy to see, but they are also quite low to the horizon. So you got to get a good, clear view of the sky. So if you're driving out of the city, try and get to a place where your south and your west horizons are nice and flat without too many trees, or, I mean, there's no hills or mountains usually to be in the way here in Manitoba, but those are the kinds of things you want to try and avoid. Oops. Way off in the west, in the eastern sky, we're starting to see the fall constellations. Now don't fear, summer's not over, but astronomically speaking, we do get a glimpse of the fall constellations. Our W shape of Cassiopeia. We'll come back to that a little bit later in the show because that's a useful signpost for us. And just rising up after dark is the great square of Pegasus. We talked about Pegasus last week. Pegasus supposedly a flying horse, but to me doesn't look at all like a flying horse. I mean, to me this is a baseball diamond. Actually, this is, you know, if you're a baseball fan, this is home plate up at the top here. You got first base, second base, third base, and then you've got there's actually a faint star in here. That's kind of maybe, I don't know, the pitcher. And then there's the bat catcher over here, and here's the manager coming to yell at the umpire. It kind of looks like a baseball diamond. I highly encourage you to make up your own versions of the constellations to help you form that relationship with the stars. Because really, it doesn't really matter what the ancient peoples called things. It's about you and the sky. And whatever helps you to remember where the stars are, totally valid. Swinging back around to the northern sky, we come back to our Big Dipper. The Big Dipper, the two stars in the bowl of the Big Dipper, always pointing off to Polaris, the North Star, which is always straight north. It looks a little distorted here because we're showing so much of the sky on a flat screen, but it's always directly due north. Just skimming the northern horizon, at this time of the year, we get a lot of UFO reports because there's a bright star just above the northern horizon, and the light from the star is shining through all of the fog and the smoke from the forest fires, and it's often very turbulent, and it seems to sort of twinkle really, really actively and maybe jump around a little bit, and it'll flash different colors. That's actually just the effects of our atmosphere, the air around the Earth on the star. But it is a star, and that means it'll be in the same spot at the same time each night. So if you do see something kind of weird in the sky, the best thing to do is to go out to the same place the next night at the same time and see if that is still there. If it is, it's something out there in the sky. If it's not, then it was something closer or something that was changing. And then you've got sort of a bit more of a mystery to solve. But like I say, we get this star Capella in Auriga, the winter constellation of Auriga, gets reported a lot right now because of the turbulence near the horizon and the flashing of the colors and things like that. Let's see here. A bunch of things all went by. Well, somebody was saying they got to meet Mark Wachowski, the Mars camera guy. Is that the guy that's out in Minnedosa? That's Impossible Players on YouTube is talking about that. There was on the Mars rover, some of you may know this, there was a camera that was used for landing that was built here in Manitoba, in Minnedosa, by a little company. And, you know, they got the contract from NASA to build these things, and now they're on Mars. So it's pretty cool to see all these different connections for how the space program works and so on. Okay, we're going to do something a little bit different here. We're going to, I'm going to turn off our Stellarium software. That's the program that we've been using here with the constellations, the stars, and I've used it every week to demonstrate some things. Well, what I wanted to show tonight with the Milky Way needed something a little bit more powerful. I mean, Stellarium is awesome software. It's free software. You can download it, but it's designed for here on Earth, really. It doesn't really let you fly around in space like our real planetarium does downtown. And so I went to the planetarium and I recorded some segments using the Digistar system. That's what flies the main planetarium at the Manitoba Museum. And we're going to talk about the Milky Way using that. So we'll flip over here. This is our Digistar sky. And here we are facing south. And you can see, of course, the Milky Way. We'll draw in the summer triangle there because the summer triangle is you know, a useful signpost for everybody. We're looking at basically half the sky here. So here's the southern horizon at the bottom, and then on the east and the west are on the left. So this is sort of half the sky. The Milky Way goes right through the summer triangle and then down towards the southern horizon, towards some other constellations that we just don't get a great view of. We get, at this time of the year, they're just over the southern horizon. There's a Scorpio just over my shoulder, which kind of looks like a scorpion. And then this one over here is Sagittarius, which it looks kind of like a teapot there, but it's supposed to be the Archer, a centaur, half person, half horse, with a bow and arrow. Okay, to me, the teapot of Sagittarius is something that I can actually spot pretty easily. And it kind of looks like the Milky Way is like the steam bubbling out of the teapot. So it's a useful signpost. This Milky Way is best viewed from a nice dark sky. You really need to get away from city lights, from the moon and all that stuff to get a good view of it, because the stars that make up the Milky Way, all this fuzzy stuff, is actually clusters of billions of stars, but they're very faint and they're very far away. And so any other extraneous light can make it hard to see. I cannot see the Milky Way very well from my suburban backyard, except when the rest of the conditions are really perfect. No moon and a nice clear sky and no smoke in the air or anything like that. I haven't seen it much this summer, to be honest. Now, we've talked about the Milky Way before. The ancient Greeks thought it was milk spilt up there on the sky. There's a great story from Western Africa that calls the Milky Way the backbone of night, because it kind of looks like a backbone that goes right overhead and is sort of holding up the sky. It's neither of those things, though. It's actually our view of a galaxy. We live inside a galaxy, and our sun is one of a few 100 billion stars inside the galaxy. Using the planetarium, we can just fly out of the galaxy to see what it looks like from the outside, because, you know, it's really hard to tell what something looks like from the inside. If you're in a forest, you can only see the trees right around you. You have no idea how big the forest is, how far away it is, because the nearby trees, that's all you can see. Well, here's our nearby trees. The little circle there, that is pretty much all the stars you can see at night. They're all within that little circle. There's a few brighter ones that we can see from a longer distance, but that's pretty much the stuff that we see. Tiny little piece of this beautiful spiral shape made of billions of stars. This is the Milky Way galaxy seen from above. And as you can see, there's lots of stars, so many that they just look like a big blur in the center there. It's not perfectly round like a whirlpool. There's actually this, what's called a bar. It's a long oval-shaped thing that is the center of the galaxy. And then coming out from there are these spiral arms that go around. And in the spiral arms, you can see there are clusters of stars, and there's little wisps of gas called nebula. Those are the places where stars are being formed. Stars are being born. Stars are dying throughout the galaxy all the time. Outside the galaxy, you can see those tiny little clusters, those tiny little spots. Those are clusters of stars. They're called globular star clusters. Each one probably has a few 100,000 stars in it. So like not as much as a galaxy, just a tiny little cluster of stars. We talked about, I think, M13, the cluster in Hercules. That's one of those globular star clusters. So when you're looking at that little fuzzy thing in your binoculars, you're actually seeing a ball made of 1 million stars that is outside the galaxy orbiting around it, held by gravity. It's pretty cool. So this is the top view of the galaxy, and it's basically big and round. What does it look like if we look at it from another angle? You know, instead of looking down on it, let's fly out and look at it from the edge and see what the side view is like. So to do that, we're going to travel much faster than any human or any spacecraft or anything has ever done. This is not an actual photograph that people have taken. This is a model that has been put together based on real data, based on the actual information, but it is not a picture that anybody has seen yet. When I recorded this, there we go. Let's fly in towards the edge, and we start to get a true sense of what the Milky Way is shaped like. It's big and round from the top, but it's pretty thin when you look at it from the edge. In fact, it kind of looks like a pizza. I mean, basically big and round and thin. Or for those of you that listen to vinyl, kind of looks like a record. And we, again, are still in that little circle. Right in the very center of that circle, completely lost to sight, would be a tiny little pinprick that would be the sun. And even smaller than that would be our planet, totally lost at this scale. But here you can see the Milky Way really has this view that it's kind of a long band across the sky. I mean, if you imagine us sitting in here, when you look this way, when you look along the band, you see all the stars of the Milky Way. If you look in the other directions, you just see a few stars and then the empty blackness of space beyond. So this is actually kind of the view that we have from the inside too. If we now use the Digistar, I'm just going to set the time here to get us back to our view from the Earth. We'll fly back to the to our home world, as it were. That's pretty much the view that we get when we're looking out at Earth. We see the Milky Way as this narrow band of light that doesn't cover the whole sky. There's the center part of it, just coming around the left-hand side of the Earth. That's where the middle of the Milky Way is. You can see it's a lot of dust, a lot of stars in that area. Then it sort of thins out from there and stretches all the way around us because we are inside it. So when you're out looking at the Milky Way, that's what you're seeing, that huge pinwheel of stars inside. The Science Star Club has asked, why is it curved? That's just because of the fact that we're showing a planetarium projection, which is normally on a round screen, and it's just coming out onto your flat screen. It would be, if we did this in the planetarium, it would be completely straight, basically. There's the summer triangle going by. You can see the same stars that we saw. There's Cassiopeia right in the middle of the Milky Way. So when you look at Cassiopeia, you're actually looking at the Milky Way, but not in the center direction. You're actually looking out towards the edge. So that's the thinnest part of the Milky Way. Now, interestingly, just down below Cassiopeia, there's another little fuzzy spot. You might sort of see this little cigar-shaped fuzzy spot just down from the right-hand side of Cassiopeia. That is another galaxy, and we'll talk about that. That's normally a fall object, but you can start to see it now. So this view, the Milky Way galaxy, is something that you really need those dark skies to see. And so I highly recommend you get outside the city, go out and whether you're camping or even if you just drive to the edge of the city if you can, or if you can't do that, come down to the planetarium. We do a pretty good simulation of it in the 2:30 show when we're doing the live show. You get to see the grandeur of the stars and the Milky Way and all the constellations and things like that. So definitely worthwhile. Now there's a part of the Milky Way that we never see. It's not visible from here in Manitoba. It's only visible from the southern hemisphere of the world because, of course, the world is round. And if you're, on the top part, you can't see through it to whatever stars are down below. You have to travel along the surface. Things like the Southern Cross and Centaurus, those are the constellations that are in the Milky Way in the southern part, down below our view of Sagittarius and Scorpio and so on. The Southern Cross is something I've never seen yet. I'd like to get far enough south to see that. I have been down to southern Texas, and you can start to see Centaurus, but the Southern Cross is just a little bit too far. So I think you have to be a little bit farther down to see that. So the Milky Way is really one of the major highlights of a nice dark sky. And if we just sort of fly back to our earthly view here and get rid of the the all-encompassing view that we could have, there's what we see, that band of light standing up from the horizon. Basically, the center of the Milky Way is along the horizon for us in summer months and stretching up all the way up overhead and then stretching around to the other side of the sky where Cassiopeia is, all the way over into the north, is half of the Milky Way's spiral arms. And we're inside those spiral arms, and that's the view that we get. Let's see, some excellent questions coming through in the chat. Becky's asking, what are the stars beyond the Milky Way when we viewed the disk view? Well, it looked like they were stars, but they were actually those globular star clusters that I talked about. So instead of a single star, they were a cluster of several 100,000 stars. There are probably some isolated stars out between the galaxies, like out beyond the Milky Way. Stars will have, maybe passed too close to another one and the gravity will have shot it off and it's now flying, out in interstellar space or intergalactic space somewhere. But we can't see them. They're so far away, so faint that we just really can't see that kind of stuff. So most of the things that you see out beyond the galaxy are either the globular clusters or they're other galaxies. Michelle was just talking about the LMC, the Large Magellanic Cloud. Let me see if I can just bring us back here to that view. I think I can. So as we here we are back outside the outside the galaxy. Right at the bottom there's another little fuzzy patch, and there's another one just skimming the horizon there. Those are two separate galaxies. You can't see them from Manitoba. They are only visible from the southern hemisphere. They're called the Large and Small Magellanic Clouds because they were discovered, or, well, they were named by Europeans when Magellan was sailing around the southern oceans. Of course, the people that already lived there knew fully about them. But the Large and Small Magellanic Clouds are other galaxies, satellite galaxies of the Milky Way. They actually go around the Milky Way galaxy, kind of like the moon goes around the Earth. Galaxies aren't by themselves. And in fact, as we'll see when we flip over to our next set of views here, we will find that the Milky Way is also far from alone. Hang on, here we go. So this is the Andromeda Galaxy, that little fuzzy thing that I pointed out. This is an image through a pretty small backyard telescope. It's also a spiral galaxy, but we see it kind of edge on, not perfectly edge on, so it's not like that thin thing, but it's also a pizza of stars angled a little bit to us. And you can see the dark dust lanes in between the spiral arms. You can see the yellowy stars in the center and the new blue stars that are out in the arms. There's a couple of satellite galaxies there as well. There's one right over here, then there's one over there on the top. So Andromeda is so far away from us that the light that is traveling to our eyes, and you can see it with your unaided eye on a dark night. If you go out, this new moon weekend and look off towards the east, you'll be able to see it underneath Cassiopeia, basically. It looks like a tiny little fuzzy spot, but it is another galaxy, and the light that is entering your eyes tonight has been traveling for 2.5 million years. It's so far away that even at the speed of light, at warp 1 for you Star Trek fans, 2.5 million years travel time. So you're actually seeing what the galaxy was like 2.5 million years ago, because anything that happened that is giving off light, that light has to travel all the way to us before we know about it. Yasmina's asking, do galaxies always have the same shape? Well, spiral galaxies do, because they're shaped like spirals. That's one of the major types of galaxies. But as we look throughout the universe, they come in all shapes and sizes. There are spirals, there are what we call elliptical galaxies that are just kind of conglomerations of stars. Some of them are round, some of them are like a football. There are galaxies that are interacting with each other and twisting around and turning. There are all sorts of shapes of galaxies. This is an image from the Hubble Space Telescope called the Ultra Deep Field. They basically pointed the telescope at a blank point of sky where there were no stars from our galaxy and took I think it was like a 36-hour exposure or something like that with the sensitive cameras. Every dot in this picture, except for this one here, this one with the rainbow spikes on it, that's a star in our galaxy. Every other dot is another galaxy beyond ours. And this is an area of sky smaller than your pinky held out at arm's length. If you hold your pinky out up against the sky, this is smaller than that area. And I don't know how many galaxies there are in there. There must be thousands. I have not counted all the dots. So imagine thousands of galaxies per pinky finger. How many pinky fingers to cover the entire sky if you went all the way around? That's how big space is. And you can see so much of it from a dark location. I mean, sure, we're not going to see all of these galaxies, but you can see the Andromeda Galaxy with your unaided eye. You can see it really well in binoculars or a small telescope. The Milky Way, beautiful to look at with binoculars. And you can see the star clouds, the little fuzzy spots of gas, little clusters of stars where stars have all formed together. All of these things are perfect for the new moon weekend. You just won't see them when the moon is up, because the moon just puts out so much competing light that these faint lights just fade into the background. And that's the same for, being in the city. So you ideally, to see these, you want to get away from all of these lights, because the light from the universe is pretty faint by the time it reaches us here on Earth. Now, Tiffany asks a really interesting question. Is there any way of learning what's happening out there without relying on light? if Andromeda had completely expanded and is no longer recognizable after 2.5 million years. I mean, how would we know? You have touched on the fundamental limitation of astronomy. The only way right now that we can learn about anything beyond our solar system is by looking at whatever light it emits to us. Sometimes that's the light that your eyes and my eyes can see, like starlight or things like that. Sometimes it's infrared or ultraviolet light that we need special detectors to see. Sometimes it's even exotic kinds of things like X-rays or gamma rays or radio waves. That's a kind of light that we can use to observe things out there in the universe. But literally, that's all we can do. There's no way for us to travel there. There's no way for us to have information that travels any faster than that speed of light. And so when we look at things that are far away, we're not seeing them as they are now. We're seeing them as they were in the past. And so we don't really know what the faraway galaxies look like now. We don't even know if they're there. I mean, it's entirely possible, even with the stars at night. If you go outside and you look at Deneb in the Summer Triangle, it's 1,600 light years away. So if it blew up tonight, we would not know that for 1,600 years, because the light that was already traveling, that had already been emitted over the last 1,600 years, would still be traveling and get to us. And we wouldn't find out that there had been an explosion until 1,600 years later. I mean, Deneb might not even exist anymore. And we wouldn't know about it until the information is brought to us at the speed of light. And Michelle's pointing out there's gravitational waves. There's another way that we can probe the universe. That's sort of a very, I guess, exotic kind of way. Now that we understand a little bit more about how gravity works and the universe is not as simple as we had supposed. So there are a few ways to do this. But it's really cool that the average person can still go outside with the old Mark I eyeball and just look up and see things and still get a sense of that vastness, of that immensity that's out there. If you want a sense of perspective, if you want to feel small, astronomy is definitely the way to do it. All right, let me see here. Some good conversation going on in the chat there. A little bit of talk about the universe expanding. The space between things is expanding as the universe expands since the Big Bang. It can get pretty complicated pretty fast. I mean, and quite honestly, I just get to the point where my mind explodes and I just stop thinking about it intellectually and just sort of drink in the photons of light as they come into my head. I think it's super cool that I look at the Andromeda Galaxy, and actual little pieces of light that used to be part of that galaxy have traveled all the way here and have gone into my head, inside my eye. So I'm carrying around stuff that used to be in the Andromeda Galaxy. So anyway, I said cool or whatever about 12 times there. Sorry, I need a better adjective, but it really is kind of mind-blowing when you start to think about these distances and what it is that we're seeing. It's not just the beauty of something that you see that is physically pleasant to look at. It's understanding what it is and what it represents that can really make the experience even more profound, I think. Okay, I think now it's time for
Cool Space Stuff!
So the Nauka module, the Russian spacecraft, has docked to the International Space Station. We talked about this last week. It happened just a week ago. There was a major issue with the engines suddenly turning on randomly. It was terrifying. NASA was sort of downplaying it. Everybody was like, no, everything's fine, everything's fine. Over the next couple of days, more information came out in terms of, what went on. And it turns out that there were some serious problems. No one was in danger. The crew was not like, oh, we have to evacuate. but there could have been damage to the space station, and certainly there's some issues to be tracked down. The Nauka module, basically, there was no off switch that the astronauts themselves could get to. They had to wait until the whole space station went around the world and got over Russia again, and Russia could then communicate and turn off the engine. So there were some problems there. That's all fixed. The engines are out of fuel, basically, which is fine because they don't need them anymore because it's on the space station. But so they've gone inside. The astronauts are starting to unpack some of the cool science equipment and stuff like that. So I'm really looking forward to seeing what Nauka can do now that it is there safely. But it definitely was a little bit of a hair-raising kind of thing. It turns out that the space station actually did more than a 360 rotation. It spun around 1.5 times. Now, that sounds terrifying until you think that it took 45 minutes. So it was actually a very gentle turning. And when you're in space, you don't feel that kind of motion. So it's not like the astronauts were getting thrown against the wall or things like that. In fact, they didn't even notice until the people on the ground told them. But the whole space station did a loop-de-loop, and then finally was able to right itself. So it's good to know that is now functioning. Unfortunately, we can't see the space station from southern Manitoba for the next couple of weeks or so. It's in a position where the only time it comes over us, it's daytime, so we can't see them. And so it's going to be interesting when it comes back in I guess around the 25th of August, and we'll get a chance to see it then in the morning sky. Now, if you're not in southern Manitoba, you'll have different opportunities, of course. You can always visit the Manitoba Museum website, and that will give you all of the details of when to get the space station's sightings for your location. So you can always visit, our website, and which is manitobamuseum.ca. Click over to the planetarium page, and there's a section on current night sky, which talks about the upcoming events, talks about where the moon is and all that kind of stuff. So, useful place. If you want to send us in questions, or you have any comments or things like that, we would love to get feedback. You can hit us on Facebook or YouTube. You can email us at space@manitobamuseum.ca. You can send us cards and letters. It was awesome to get actual mail this week. So all of that information, again, is on our website, our address, and things like that if you want to do that. We have one more thing that I want to talk about before we move on to the final question segment of the show. And that is, we want to talk about the upcoming meteor shower. So the Perseid meteor shower, it's an annual event. Every August 11th, 12th, 13th, somewhere in there each year, we have this meteor shower. And people get excited about it, and they go outside and they look at the sky and they don't see a meteor shower. They might see a few meteors here or there, and they get disappointed. So I want to tell you the common problems that people do when they're observing the meteor shower. We're going to talk a little bit more about this next week, and we'll have some images from next week. But the key thing about a meteor shower is that it doesn't really turn on until after midnight. That's a big thing that you almost never hear about. The meteor showers, the way they sort of work is that these little pieces of dust are all floating around in space, and the Earth is sort of moving through them, and each of those pieces of dust crashes into the air around the Earth and vaporizes, and the air heats up and glows, and you get this streak of light that we see as a shooting star, a falling star. A meteor is the official name. And so during a meteor shower, you get a bunch of these all at once. The thing is, the part of the Earth that is facing into the meteors is the part of the Earth between midnight and 6 a.m., between midnight and dawn. That's kind of like the windshield of the Earth. If you think about it like a car driving through the highway, and it's raining. You get lots of rain hitting your front windshield because the windshield is moving into the rain. It doesn't matter which way the rain is falling, the windshield gets hit with everything. The sides of the car get a little bit of rain, but it really depends on if the wind is blowing this way or the wind is blowing that way or whatever. The back of the car, your back window, doesn't get very much rain at all unless the rain really happens to be coming from that direction. Well, in the early evening, we're looking out the back window of the Earth. Around midnight, we're starting to look out the side window of the Earth. Just before the sun rises, that's when we're looking through the front windshield. And so that is when meteor showers are at their best. So meteor showers are not a late night thing, they're an early morning thing. If you aren't going to stay up all night to see a meteor shower, the best thing to do is to get up at 3 in the morning and watch from 3 till 5 in the morning. Sounds a lot less attractive to many people when you put it in those terms. Having said that, this is going to be a great year for the Perseids. That source of light pollution, the moon, is not going to be big during the peak time. The night of August 11th into the 12th, that's sort of a good time. So I would say like the morning of the 12th or the morning of the 13th, those are going to be good times. And the moon will be very, very thin crescent, and it will set very early in the evening. So the moon will be out of the way. So I'm planning to drive to a darkish location, depending on what the weather looks like. And we'll have our all-sky camera set up so that we can broadcast the meteor shower. And so that will depend on the weather, and it will depend on where we can go and so on. But we'll be broadcasting those either on the morning of the 12th or the morning of the 13th. So if you're not already a member of the Facebook page or YouTube page, you should definitely want to give us a like or a subscribe so that you get that information. You can also sign up at the Manitoba Museum's webpage for our email news list. And if you just want to see other sky stuff that's going on, or when I happen to go out observing, spur of the moment, you can always follow me on Facebook at Scott the Skywatcher. And that way sometimes you get some bonus content, I guess. Okay. We've got time for a couple of questions here, so if anyone has questions, now's a great time to pop them into the chat. We got a question here from Melissa. Is the James Webb Space Telescope proposed to provide better imaging compared to Hubble? Yes. The James Webb Space Telescope is supposed to basically replace the Hubble Space Telescope. Its optics are about 10 times as big. No, sorry, 3 times as big. And it has got much more sensitive equipment. I mean, Hubble was launched in 1990. Computers and cameras and things like that back then were not the same. It was upgraded a few times with the space shuttle, but it's still not sort of cutting edge anymore. And so the next generation space telescope, the James Webb Space Telescope, is going to be amazing. It'll be a whole nother leap forward in terms of the kinds of things we can see, whether it's planets around other stars or whether it's close-up views of distant galaxies or those kinds of things. It's going to be a game changer, just like Hubble was. It's a very complicated spacecraft. It's taken a long time to put together. It's well behind schedule and well over budget, but it's going to be worth it because it will be, like I say, a game changer. There are still images from the Hubble Space Telescope that haven't been fully analyzed because there's just so much science that can be done on them, and it's going to be the same kind of thing with James Webb. Let's see. Oh yeah, next Friday we have a Friday the 13th. That's a good point. Interesting. I tend not to be too superstitious. Actually, to be honest, I tend not to know what the date is if I'm being honest. Since the pandemic hit, I have no idea what day it is. I just, there's today and there's tomorrow. Nothing else really matters. But yeah, the Friday the 13th coming up, that's actually the night of the next meeting of the Astronomical Society, the RASC. And so that's something that you can find out about on the website as well. It's a great group of folks, and they have presentations kind of like this and also on a variety of other topics, very focused on the kinds of things you can see in the sky and stuff like that. It's a great group of people. If you're considering, doing this on a regular basis, looking at the sky, certainly is a great group of folks to join. They even have telescopes that, once COVID is sort of over and done with, they have telescopes that you can borrow, like the library kind of thing. So that's a really attractive element. That was why I joined, was so I could borrow their telescopes and figure out what I wanted to get. Ben's saying, I heard anyone can book time on Hubble, but I don't know how much longer it's operational. There are some small numbers of time that is allocated through different projects that an average person like you and me could submit a suggestion for Hubble. It's pretty few and far between, though, and because there's a lot of science that only Hubble can do, or Hubble observations are critical to be able to sort of work with. So I don't know when they've done a public one recently. With the failure that they had a couple of months ago where Hubble was down for like a month, everything is all backed up right now. And yeah, we really don't know how much longer Hubble will continue to function. Every day at this point is a gift, because it was supposed to last until, I think, 2005. So we are well past the warranty date. We've certainly got our money's worth on Hubble. So having said that, there are a bunch of online telescopes. There's a group called SLOOH, SLOOH, that you can basically sign on to, and for a membership fee, you can basically use their telescopes and just take pictures of whatever you want. There's the iTelescope network. There's a bunch of places like that where you could just basically submit a proposal and they will take the pictures for you and send them to you. So you can do citizen science. In fact, right now I'm doing that kind of thing with a telescope out in Halifax, where I'm observing variable stars that actually pulsate and get bigger and smaller on a periodic time scale. And so that's one of my research interests, sort of on the side, is working with that. If I had to have my own telescope do all of that, it would take forever. But through this kind of partnership, it's a very effective way for amateur astronomers to do real science. So, plus, you don't even have to worry about the science. If you want, you can just go out there and look at the beauty and enjoy the sky. All right, this brings us to the end of another show. Thank you all. The time always flies with the group here. It's so nice to chat with you all. If you do have any questions you'd like, or topics that you'd like us to cover, please drop us a line. We are going to be fitting in sometime in the next couple of weeks some solar imaging with Dr. Michelle Boyce from the University of Manitoba, and so that'll be exciting. We're also looking at talking about some nuts and bolts of telescopes with some of the local folks, so we'll hopefully get some of that stuff on the schedule soon. And the show apparently will be continuing in September as well, so thank you. If you haven't already filled out one of our surveys, I will drop that link in the chat after the show closes, and please fill that out. Our bosses really love to know how many people watch the show and all that kind of stuff, so it's really, really useful for us. It only takes a couple of minutes. We don't ask too many probing questions. We don't spam you or anything like that. So thank you all. I hope I get a chance to see you down at our place at the planetarium in the near future. If not, keep in touch, and I hope you enjoy some clear skies.